Example number 5. Two ships are steaming away from a point along routes that make 120 degrees. One ship going to one side and then the other ship moves in a different direction with an angle that is 120 degrees in the middle. The two ships A and B move at 14 knots and 21 knots, or technically that's the unit for nautical miles per hour, respectively. How fast are the ships moving apart when OA equals 5 and OB equals 3 nautical miles? Looking at this picture, we have 3 lines, and these 3 lines will create a triangle, not a right triangle. This is a scaling triangle. So in order to bring everything together, we cannot use SOHCAHTOA anymore. We need to make use of either sine law or cosine law for this related rate problem. We have the line from O to A, we have the line from O to B, and we have the angle in the middle. Based on what is given, I probably will use the cosine law to figure out how far are these two ships moving apart. So in this case, if I'm to consider this triangle as OAB, then using cosine law, I can set up an equation that looks like this. But of course, you probably don't like working with AB, OA, OB. You probably want to make a substitution here. Let me consider this as x, something that we are trying to solve. So we have x squared equals OA and OB. Let me call this a squared b squared minus 2ab cos theta. Now, knowing how theta is 120 degrees, I'm going to make my substitution right away. As I differentiate both sides of the equation with respect to t, this will give us 2x times dx dt. We are trying to find dx dt. How fast is this distance increasing with respect to time? Equals 2a times dA dt, 2b times dB dt, dA dt, dB dt. These are just the speed of the two ships, minus 2 times AB cos 120. Cosine 120 give us an exact value. Cos 120 degrees, we're talking about an angle in quadrant number 2 with a reference angle of 60 degrees. And this will give us root 3, 2, and 1 negative. So cosine 120 degrees would then be negative 1/2. And as you times it by the 2 here with a negative, that will turn into plus AB. So if you want to differentiate this with respect to time, we will end up with product rule. Differentiate the first part and leave out the second, plus leave out the first part and differentiate the second part. And once again, these two are the speed of the boats. When a equals 5, and the nautical miles for the first boat is 14, I can substitute the numbers into the equation, and when OB equals 3, plug in the number, and here the speed is 21, plus 14 for the speed, and the distance for B is 3. 5 times 21, and on the left hand side we still have dx by dt times by 2x. And to figure out what is x, I can probably use the cosine law. At this time, with 120 degree, 5 here and 3 there, you can set up your cosine law and calculate this value. With 5 squared plus 3 squared minus 2 times 5 and 3, cosine 120 degree. You probably will end up with 49 in this case, and taking the square root of this equals 7. So with 7 on this side, I can now solve for dx dt by having this whole thing divided by 2 times 7. So in this case, we will end up with the speed of how these two ships are moving apart.